Okay, any question about your SI pass? Good. And as I told you from February, I'm going to assign extra credits for each SI pass session that you attend, or tutoring, or tutoring with myself, office hours, any activity that shows you're learning. For 1 hour of that, I give you 5 points extra credits. Okay. So before we start chapter 10, anyone has any questions from chapter 9? Okay, I just wanted to remind you, your final exam is 200 points, and your next exam, which is 1 week from now, next Friday, is out of 100, and you have another quiz, which is 40 points. So you have 340 points remaining, okay? So make sure that you study these materials well and ask me if you have any questions. So good news is that I'm going to eliminate chapters 1, 2, 3 from your final exam. So I guess I do that. 1, 2, 3 won't be on your final exam. So motivates you to focus on chapters 4 to 10 for your final. 4, 5, 6, 7, 8, 9, 10 would be on your final exam. And for exam 3, which is basically in our next Friday, the materials would be from chapters 7, 8, 9, 10. So how much of chapter 10 that I can finish would be on the exam? So I'm going to start chapter 10 today because you're going to run the lab next week needing these materials. So I want to progress with the lecture so you have a fairly short lab, okay? Because if you don't know the materials, first you should learn them, and the lab would be much more difficult for you. So I talk about chapter 10, try to progress today and on Monday, and after I progress the lecture to the point I want, I go back to the calculations to prepare you for exam 3 more. Okay, and as you saw, assigning extra credit opportunities in each lecture, and sometimes like today it would be 10 points. Okay, so even if you did bad on one of your homeworks, or even if you missed one homework, this is a great way to make up for that. Okay, so I always tell my colleagues and also my students that people who fail this class, they literally wanted to fail because I provide so many extra credit opportunities and so many makeup opportunities. I mean, you had makeup exam 2 opportunity, and then previously to some of your homeworks and quizzes at the beginning of the semester. And do you have any other professor that they give you extra credit opportunities? So I'm willing to do everything I can to make sure that you all learn and succeed. Okay? So I keep doing those, and I was grading your extra credit quizzes. But as you noticed, and you received an email from Deb, and also saw probably my Canvas notification, I didn't have my account for 30 hours, which delayed, putting grades on Canvas and all that. So this weekend I'm gonna catch up on all the grading of your makeup exams, putting everything on Canvas so you see the grade change and kind of motivates you to study and then get good grades. So something I wanted to tell you and ask you to do is that to take a screenshot or remember your grades for each homework and quiz and exam, because when I update, your exam 2 grade, for those of you who took exam 2 or quiz 3, you may or may not see a change. And I'm going to give you next class your extra credit, anything that you handed to me for your, makeup exam or extra credits, so you have them to study for your next exam and also for your final exam. So what I'm saying is that if I want to add 10 points I look at your grades. If someone is lacking some points in their exam too, I add that to that exam. Or like if someone missed the homework, I add that to that specific homework. And the reason that I do that is that last semester, I was adding everything in the last minute, and students couldn't see the change in their grade book on Canvas. And they were asking me, where is my grade? Where is those extra points? So I want you to be able to see that. But if I add them on Canvas and as 0 points, again, you don't see the grade change. Does that make sense? So just remember your points, however you want to do that, whether take a screenshot or just write them down. And then on Monday, when I come to the class, or like before that, I ask you to look at your grades, and if you handed extra credit opportunity, or like quiz to me, and you don't see any difference, tell me, so I make sure that I didn't make any mistakes. Does that make sense? The whole thing? And these extra credit quizzes is from anything that I talk about in that specific lecture. So today, for today's class, anything that I talk about, I'm going to ask you at the end to see if whether or not you learned them or not. And on average, now we have like a less crowded class, but one of the ones that I graded, out of 80 people, 20 people didn't answer questions well. And it tells me those are people who are not paying attention to the class. And as I said, for me to help you get a good grade, you should kind of participate too and let me help you. Okay, any question about any of this? Good? So today I'm going to talk about bonding models. Any of you have any idea of what bonding means? When I'm talking about chemical bonds or like bonding models in general, what do you think they mean? So if you consider water molecule, what is the formula of water? Exactly. So we have 2 hydrogen atoms for 1 oxygen atom, right? H2O. And if you want to draw the structure of H2O, that would be the structure that I have here. So that is kind of 3D structure. The one here is like a structural formula, and then here is just like molecular formula. So now in today's lecture, we want to study why water is bent. Why is it like straight like CO2 that I listed below? Or each, when we attach atoms with each other, we do that through chemical bonds. And depending on what type of compound we can have ionic bonds or covalent bonds, which they correspond to ionic compounds and molecular compounds that we talked about in chapter 5. And I have like all those listed in bullet points. I know some of you love bullet points, and I had some students that telling me that they didn't see bullets in some of the slides and they were so upset. So that's why I have like the bullet points that some of you are interested in. So you have that. And just as a reminder, I also posted all the study guides on Canvas and all the last semester exams. So for those of you who want to have questions before answering homework problems or before preparation for exam, I have everything there like a few weeks ago. So you have everything available for you. Anyway, so bonding models tell us how atoms bond together and form compounds. And depending on how they bond together, we have different types of compounds that I have in the next slide. But as I said, I'm trying not to go back and forth between the slides so it won't get confusing. And also when I'm recording, each recording corresponds to one slide, so the software cuts out me talking when I go back and forth. So I try to prevent that. So bonding theory and bonding models in general there are models. Remember that theory and the other name of theories were models, so those are the same. That predicts how atoms bond together to form molecules, okay, or form compounds. So if I tell you, is the following statement true or false? Bonding theories tell us how atoms bond together to form mixtures. False, right? Remember, mixtures, when we have like some substances and then we just add them together when we dissolve sugar in water, they're not chemically bonding. It's not like that water forms bond, with your sugar. So that is just a mixture. So that is different, remember. And bonding theories are really important because they predict different things. One thing that they predict is that why do I have NaCl, right? We talked about that in detail in chapter 5, but we don't have NaCl2. Or why water is H2O? Why isn't it H3O or HO, right? Bonding theories tell us why that is. Or the other thing that they tell us is that, how atoms bond together to form compounds, which is basically similar to what I just mentioned. Or which combination of atoms form compounds and which combinations do not. So it's not like that any element in periodic table you attach to another element and then you have a compound, right? There are like certain elements that form chemical bonds with one another. This is another thing that bonding theories help us learn. Or like why salt is NaCl, not NaCl2, or why water is H2O, not H3O. Bonding theories also help us explain the shape of molecules. As I mentioned, CO2 molecule, carbon dioxide, is linear. It's not bent, but water is bent, and this is the subject of your lab next week, the shape of molecules. You're trying to predict, these shapes. And shapes of molecules can determine some of or many of their physical and chemical properties. So basically, bonding theories indirectly can also predict many of the physical and chemical properties of your compounds. Sometimes I'm just thinking that, is someone taught me, or do I have schizophrenia? Anyway, any questions? Good? So this slide is one of the questions that I asked you today. That which of the following statements bonding theories cannot predict. So if you know what they can predict, you can easily answer that question. Is it clear what are bonding theories? What do we want to accomplish here? Okay. Now, there are like several different bonding theories, and some of them are really complicated. But in this class, we just studied one of the really simple ones, which is Lewis model. Okay, and Lewis model is a really simple model. It's not complicated, and hopefully we all can answer the question that I asked you in exam. So it's a simple model for a chemical bond in which atoms transfer or share electrons. Can anyone tell me, based on what we studied in chapter 5, what type of compounds do you think they transfer electrons? Or what type of elements, I should say? Metals, yes. So metals is a good example. They lose electrons, right? So they transfer electrons. So if I consider magnesium, for instance, Mg2+. And as I told you several times, I expect you to know that all the elements in group 2A, when these are metals, and then when they want to form a cation, meaning losing electrons, they lose 2 electrons, so we'll be having Mg2+. What is the name of this cation? What do we call this? Anyone?
Magnesium 2+.
So you don't have to say 2+, but magnesium, yes. But if it was Cu 2+, Cu is copper, what would that be? That would write copper 2, remember? But for magnesium, we don't have to write the charge. We just call it magnesium, and we don't change for metals, for cations, we don't change the name. It's straightforward. Now, let me ask you this. What about Cl? So chlorine, if it wants to bond with a metal, would that gain or lose electrons? Gains, right? And then what would be its charge? Minus, exactly. What is the name of this anion? Chloride, exactly. You have the base name of nonmetal plus IDE. So remember, for nonmetals, we add IDE to the base name of nonmetal, so the name changes. But for metals, the name doesn't change. But if they have multiple types of charge, we write the charge with Roman numerals in parentheses. So these are kind of review of chapter 5, but it's related to what we are talking about here. So now, if I want to form a compound between magnesium ion and chloride ion, what would that be? What is it? Do you remember you just switch these ones and then you say MgCl2? And what was the name of this? Magnesium chloride, exactly. So what happened here is that magnesium has lost 2 electrons, and chloride, we have 2 chloride atoms, as you can see here, right? 2 of them. Each of them gained 1 electron from magnesium. So here we are dealing with transfer of electrons. In ionic compounds, electrons are being transferred. Okay? But when we have molecular compounds, which are, non-metals, when they form bonds with each other, they share electrons. They don't lose electrons. We don't have cations and anions in molecular compounds, remember? So we have 2 nonmetals that they share electrons, and we call that type of bond covalent bond, that I have in the next slide, the definitions for you. But before I go to the next slide, let's study Lewis model again. So it's a simple model for a chemical bond. So when I say chemical bond, it can be ionic, it can be covalent. Which one corresponds to molecular compounds? Covalent, because we're sharing electrons. Okay? So chemical bond in which atoms transfer, as I said, transfer is for ionic, and don't worry, I have everything written in the next slide, or share electrons. And for sharing electrons, I use another color, which is covalent. To attain a noble gas electron configuration, usually referred to an octet. And I mentioned this briefly when I was starting to teach chapter 9 and also at the end of it, that the reason chlorine gains 1 electron is that at the outermost shell, it has 7 electrons, right? That we call that valence electrons, right? The electrons in the outermost shell. And chlorine likes to reach the electron configuration of the noble gas after it, which is argon, which has 8 electrons in outermost shell. For that matter, it only gains 1 electron. And the same thing for sodium. Sodium has, how many electrons does it have in the valence shell? 1 because it's in group 1A, right? As long as you know the main group elements, or you look at the periodic table and be able to identify group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, you should be able to just know how many valence electrons they have. Sodium has 1 valence electrons. Do you think it's easier for sodium to lose that electron or gain 7 more? Lose 1 electron, right? So it loses that electron and reaches the electron configuration of neon, the noble gas before it that has 8 electrons in its valence shell. So except some exceptions, which are like hydrogen, helium, lithium, beryllium, that they don't have, they don't reach, octet, meaning that they don't, for instance, beryllium, it has like 2 electrons in its valence shell, right? It loses 2 electrons and reaches electron configuration of helium, which has only 2 electrons. Except hydrogen, helium, lithium, beryllium, all other elements, they want to reach an octet, meaning having 8 electrons in their outermost shell. Does that make sense? Any question? So when I say octet, I'm referring to the fact that noble gases, they have like 8 electrons in their valence shell. Okay? Good? Questions? Okay, so that is Lewis model. And now, today, we want to talk about Lewis structure and dot structure. And some students were really confused last semester that they, in their homeworks on Canvas, we were using BBLearn at the time, but it was hard for me to type electrons or like draw a structure, so I didn't give them any questions on BBLearn about dot structures, and they thought I'm not going to ask them. And although I gave them handouts in the class, I had like study guide that I wrote and all that, and then in the exam I just wrote, hand wrote the questions about this section, and they didn't score well because of the reason that I just mentioned. So for this part of the class, I'm going to add those questions, just like write them. So study these well as other materials that you study. Okay, so dot structure or Lewis structure, as we said, is a really simple model. What we do, we write the chemical or atomic symbol of an element, and we put the valence electrons by dots around it. What that means is that if we have lithium, I just write lithium, and then I look at the periodic table or remember which group lithium is located at. Where is lithium? 1A. How many valence electrons it has? 1. So I just put 1 electron here. And you're welcome to put it any side of lithium you want. You can also put it here, or like here, or here. All are correct. Absolutely doesn't matter where you put it. But that would be Lewis, the structure of lithium. So what I do in the exam, I tell you which of the following represents electron configuration, Lewis structure or dot structure of lithium, right? And one of them would be this, the other would be this, the other would be this. And that can be tricky, right? Because you should know it's valence electrons, not the whole number of electrons. And the other, this. Which one is the correct answer if this is A, B, C, D? D, right? Okay. Let's do another example. What about beryllium? How many valence electrons it has? 2. And as I mentioned, it doesn't matter where you put them. But something that is really helpful when we want to, as you may guess, we put these valence electrons as dots, and then when we want to have compounds, we connect these dots or electrons with one another. So it's a good practice to also use the equivalent of Hund's rule here, meaning that if you have carbon, for instance, what is the atomic number of carbon? 6. And how many valence electrons it has? Or which group is that?
4.
Exactly. Group 4A, right? 14 or 4A. So how many valence electrons it has? So remember, we're dealing with valence electrons, not the whole number of electrons or atomic number. So you write carbon, and then you want to put 4 electrons. So what we do, like Hans' rule, that you fill orbitals singly first, then you pair them up. Here, do the same. Put 1 electron here, and then we put on 4 sides of carbon, right? And all your elements. 1, 2, 3, 4. That would be dot structure, guess I right, or Lewis structure for carbon. Let's do another example, and I write that with another color. What about fluorine? How many valence electrons it has? 7. So we start here. 1, 2, 3, 4, 5, 6, 7. And as I said, if you put these 2 dots on top, bottom, and then the other dot above, it doesn't matter. As long as you have 2 electrons on each side and 1 on the last one, that would be fine. What about neon? My software just updated itself, and now some of the features that previously was so convenient, now it's not working. Okay, let me go to another one of these. So what about neon? How many valence electrons it has? 8. So you start here, for instance, 1, 2, 3, 4, 5, 6, 7, 8. And we call that, dot structure. We say that the octet, so basically neon already has an octet, meaning that it has 8 electrons around it. Okay, but for instance, for Cl that we had 1, 2, 3, 4, 5, 6, 7, Cl wants to reach an octet. That's why it gains 1 electron. And when it gains 1 electron, what happens is that, so if you have Cl minus, if I asked you to write dot structure for Cl minus, how would you do that? You have Cl that it gained 1 electron, right? So you write the dot structure or Lewis structure for chlorine, right? And then it has 1 more electron. So you put 1 more here. So this would be Cl minus. And this is how we write it. Good? Question?
Ma'am,
Yes.
I have a question. So say that an element has 4 and wants to become an octet, is that because how much of a shared
Exactly.
Okay.
Yeah. And that is the main subject of carbon compounds that I'm teaching, and some of you might take it next semester. It's all about carbon compounds, and carbon, because it has 4 electrons in its valence shell, it can both lose or gain electrons. Okay? Or rather, what I mean is that it shares electron, but in some instances it can also lose or gain them. But in general, most of the carbon compounds, or most of the compounds that carbon forms, it shares electron. Great question. Any other question? Good. Okay, so now I have some more terminology before I talk more about how to connect these dots with another and form compounds, basically. So here, this is kind of like review of what we talked about, that the number of valence electrons for any main group element is equal to the group number of that element. And remember, when we say group number, I mean the terminology that had A in it, right? Main group elements 1A, 2A, 3A. Because in the other system, if you want to name them, for instance, for fluorine, the group would be 17, which is equivalent to 7A. When we write it with the letter A and number, whatever this number is, would be the number of valence electrons. Okay? And as we said, we have exceptions. For instance, for helium, so all the noble gases, they reach an octet, or they have an octet, meaning that in the outermost shell they have 8 electrons, but helium only has 2 electrons. So it reaches or has a duet structure, and I wrote that here. The name for the 2 electrons corresponding to a stable Lewis structure in hydrogen and helium. And the reason your noble gases are really stable is that their valence shell is filled, and they don't like to lose or gain electrons or share electrons. They're all set, and they are really stable. So that was duet, and as I said, the number of electrons, 8, around atoms with stable Lewis structures is called octet. Any questions? Good? Okay. So now, here, these things I just talked about, but to emphasize and make sure you know all of them, I'm going to talk about them again. So if I ask you in exam about chemical bond, remember, chemical bond can be ionic or covalent. Ionic bonds are type of chemical bonds. Covalent bonds are type of, chemical bonds as well. But what is the difference between an ionic bond and a covalent bond?
Ionic bonds, the electrons are transferred the way that they're shared.
Exactly. So when we had molecular compounds in chapter 5, we had 2 nonmetals, right? And I told you we can have metalloid and nonmetal as well, but definitely we don't have metals. So in those cases, when you have molecular compounds, which are like 1 or more nonmetals, or metalloid and nonmetal, we have molecular compounds, and in that case, we have covalent bonds, meaning that electrons are being shared. And when I draw the structure, that makes more sense. An ionic bond, as you remember, we had like Mg2+, Cu+, Na+, right? So the metal loses electrons, and the nonmetals gain 1 or more electrons, so it's electrons being transferred. Okay, it's not shared, electrons are being transferred. So, and here I just included everything that I just said, so for chemical bond, you can have electrons being shared or transferred. So if I give you this sentence and I say ionic bond is the bond that results when two nonmetals combined. True or false? False, right? You should have a metal and nonmetal. And I just got that exactly from your book, but as you remember, the more correct definition is when you have cation and an anion, right? Because also ammonium is NH4+, is a cation, it forms ionic compounds, but is not a metal. So that was the exception, but except that, any metal and non-metal, they form, so any metal, non-metal, they are ionic bonds, but if you have ionic bond, maybe you won't be having metal necessarily. But for the purpose of our chapter here, everything that you see would be a metal and non-metal, so you don't have to worry about it, okay? And as we said, in an ionic bond, the metal transfers 1 or more electrons to non-metal. So if I give you this sentence and I say, in an ionic bond, the non-metal transfer 1 or more electrons to metal. That won't be right? So the metal gives this electron to non-metal, non-metal gains it. Does that make sense? Questions? Okay, and covalent bond, as I said, is the bond that results when two nonmetals combine in a chemical reaction. In a covalent bond, the atoms share their electrons. And also octet rule, as we said, a rule that says that an atom will give up, accept, or share electrons. So what type of atoms give up electrons? Metals. What type of atoms accept electrons? And what type share electrons?
Group 4A.
What's that?
Group 4A.
Group 4A, but I'll also, if I have, like, for instance, BF3, here, also electrons being shared, right? So between your, as long as you don't have a metal, whether metalloids and nonmetals or like nonmetals, right? Electrons being shared. So the important thing to remember is that when you have metals, electrons being, metals give up electrons, and this is kind of interesting, Sometimes I just, don't say anything, but sometimes it just like gets to me because I'm teaching, and then some of you, distract me, and you think that, we have a, although our classroom is supposed to be large, but not all of you attend the class, so it's like fairly, medium-sized, a small class. So I see every one of you, and I know what everyone is doing. So sometimes you just think that I'm not seeing you. So what I'm saying is that I'm trying my best to be accommodating to all of you and being really respectful to all of you, and I kind of expect the same thing. So I appreciate if you also have like the mutual respect that I have for you. Okay, any question about that? Okay, so let's solve some examples before I give you the quiz. So how do you write the Lewis structure of nitrogen? What is the first thing that you do? What group is it located at? Where is nitrogen? 5A. So it has 5 valence electrons. So what you do, you write nitrogen and you put 5 electrons around it, okay? And as I said, it doesn't matter where you start, but, it's kind of like when I was like, I don't know, much younger, when I was a kid, there was like some exercises that without, having your pen lifted from the paper, just like connect something to each other. So this is the thing, if you start here, just like go in one direction, whether left to right or like right to left, but have the direction. So 1, 2, 3, 4, 5. And as I said, we just fill them, kind of put the electrons singly first and then pair them up. Are we good with like dot structures for elements? Okay, so let me go to dot structure for ionic compounds. So if I have, KCl, from before that we have like potassium, K+, and then we have chloride, Cl-, and I told you here we have 1, so you put the 1, this one here, and then this one here, so I write KCl. But now we want to know, based on the dot structure or Lewis structure, how we can interpret this or how we can write the dot structure. So what you do is that individually you write the dot structure for each of them. So what is dot structure for potassium? Okay. What is it? 1 electron, okay? And what I advise you to do is that when you want to, here it doesn't matter much because we have an ionic compound, so we're not sharing electrons. But it's a good practice to put electrons closest to the other element, especially for covalent bonds, because we want to share electrons. If you put this electron, the other side, and then you have Cl here, as I said here, it doesn't matter much because we're not sharing electrons. But for covalent bonds, when we want to connect these dots together, it doesn't work out this way. So just it's a good practice that put this electron, closer to the other element. Does that make sense? So now for chlorine, how would you write the dot structure for that? Chlorine atom itself. You put 7 electrons around it, right? So if I start here, for instance, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay? And here, try to put it somehow that the single one would be here. So 1, 2, 3, 4, 5, 6, 7. Okay, as I said, here we're not sharing electrons, so it doesn't matter. But if this compound would have been molecular, or you had like a covalent bond, I would just connect those 2 dots. So it's a good practice to just do that. So now we know, based on everything that I taught you so far, that potassium loses that electron, and when potassium loses this electron, who do you think gets that? Chlorine, right? So this electron goes here, and both of them reach an octet. Okay, so what happens is that here you have K plus, and here you have a Cl that has 8 electrons around it, and now it has a negative charge. So this would be Lewis structure or dot structure for potassium chloride. Okay? Does that make sense? Good? Okay, so to make sure that all of you have enough time, can everyone log into Canvas right now? So I have your quiz on Canvas today, and hopefully it's working. I'm going to check myself momentarily too to make sure that everything's fine. So I asked you, after we're done with this class, I'm going to delete that quiz after I download your grades. For the reason that I just mentioned at the beginning of the class, because I want to add those to your homeworks or like exams that you're lacking grades, and I want you to see the change in the grade book, and I don't want that to be added to your grades, So I don't want to mess up the whole grading system in this class. For that matter, when you answer a question, just in your notebook or anywhere in your cell phone, just write what you answered. So you have your answers after I post the solutions. Does that make sense? Question? Everyone can see their extra credit quiz? Can you see it? Okay. And in number 3, I said in ionic bond, 2 metals share electrons. So what I mean is that, just I don't mean the whole compound. Just imagine you have like one element with another, and you want to form a bond between those two. Does that make sense? Because if you just look at NaCl, for instance, you may argue that they have like several, cations. So what I mean is that just a bond between 2 atoms, or like between two elements specifically. Is that true or false?
I had a question. So I tried to submit my homework for Wednesday, and I just looked in Canvas, and apparently I didn't submit. I had this problem last week with my home assignment. Is there any way that I can do it by tonight? Because
Can you send me an email so I look at it?
yeah, sure.
Okay.
Thank you.
Perfect. Thank you.